In this next section, we'll talk about how we name alkenes and alkynes. So the rules are really pretty much always the same. There's just always subtle variances. So again, we want to find the longest chain. This time we want the longest chain that contains a double bond. Or if it's an alkyne, contains triple bond. Then we're going to number so that we give the multiple bond the lowest number possible. And when numbering, we only give the starting point of the alkene or alkyne, the starting carbon. For example, if I have 1 butene, the alkene starts at 1 and ends at 2, but I would name this 1 butene. And that would be preferable to starting at the other end and going 1, 2, 3, and calling this 3 butene. You can do the same thing with an alkyne. 1, 2, 3, 4, 5 carbons. So this is pentyne, where the lowest numbered carbon is of the multiple bond. So this is 1 pentyne. I can also draw this structure, which would be 1, 2, 3, 4, 5 this way. So this is 2 pentyne. If there's more than one pi bond, we can name things as a diene or a triene. With 4 would be a tetraene. We can also have cycloalkenes. Cycloalkynes are extremely rare just because of the fact that that bond has to be linear because of the sp hybrid orbitals. But if I have a cycloalkene, for example, now I need to figure out how to number this as well. So I've got choices. I should start with my alkene being 1 and 2, so I can either go 1, 2 this direction, which would give me 1 methyl cyclohexene, or 1 methyl cyclohex 1-ene. Or if I numbered it the opposite direction, if I started this way, it would be 1, 2, that would be 2 methyl cyclohexene. So if you've been following along with all of our naming conventions, we're pretty much always trying to get the lowest numbers possible. So the correct name for this compound would be 1 methyl cyclohexene, or we could leave the 1 off completely and just call this methyl cyclohexene. Now I'll draw another one, and you try to figure out how you should name this one. So pause the video, try to determine what its name is, and then come back and see if you're right. So the lowest numbers are if we start here 1 and 2 on the double bond. This position then would be 3. So if I was naming this, it would be 3-methyl cyclohexene. You don't have to put the 1 in, but I will just for fun on this one, just to show an example. 3-methyl cyclohex 1-ene would be one way to name it. Although again, because the number is 1 here, we can leave that out and just name it 3-methyl cyclohexene. And if we have double bonds and triple bonds in the same molecule, we name the ene first and then ine, and so we'll call it an enine. So we'll start at the end closest to the first multiple bond, but if they're the same, then alkenes get the priority. So this would be 1 for the alkene, 2, 3, 4, 5. So this is pent 1-ene 4-ine, or because the alkene is at 1, it could be pentene 4-ine. However, if they're not the same, I start at whatever one's lowest. So in this case, the alkyne is lower than the alkene just because it's closer to the end. So it would be 1, 2, 3, 4. And there are 6 atoms in this one. This is a hexene. So this would be hex 4-ene 1-ine. Now if I look a little bit at the structure of alkynes, remember now that I have a triple bond, what that means is that I have a sigma bond, I have a pi bond that's going up and down in the plane, I've got another pi bond that's forming in and out of the plane. So that's the best I can draw it that way, is that it's back into the plane back here and out of the plane here. That's one of the pi bonds, and here this red one connecting these orbitals is the other pi bond. And then because of that, in its sp hybrid orbitals, the other empty orbital for each of these carbons is linear. It's straight out from the carbons. So any other bonds that it's going to make have to be straight out from the ends of the triple bond.